All right, friends, here we go. Another installment of the special topics videos to help you get ready for the AP Calculus exam. Today we're going to look at two free response questions from page 72 of the special topics packet. If you are in Mr. DeRozier's class at Southwest, the special word for today is the Justice League. Yes, the Justice League. Tell me who your favorite character is in the Justice League. Get it right, and there might be some bonus credit coming your way. I would also fully accept Wonder Woman as a favorite character, but that's about it. All right, friends, here we go. Differential equations, equations that involve derivatives. We didn't spend a lot of time here, but you all did a really good job. This tends to be a place where students can earn lots and lots of points, and let's make sure that things are really tight for us. So I pulled a question from the 2005 AP exam. This is question number 6. It's calculator inactive, and I changed it up a little bit. Okay. It says, consider the differential equation dy dx is equal to negative 2x over y. Okay. On the axes provided, sketch a slope field, key phrase here, slope field, for the given differential equation at the 12 points indicated. A slope field, you probably remember, is well named. It is a field. It's a collection of tangent lines. What we're going to do is we're going to find the slope at each point using the differential equation. So, for example, if I take this point over here, negative 1, 2, and I say dy dx at negative 1, 2. Well, x is negative 1, y is 2. We're going to plug this in, negative 2 times negative 1 over 2, and we're going to get a slope of 1. What you're then going to do is you go back to that exact same point, and you're going to draw in a little tangent line segment with a slope of 1. Now, you might say, wait, is that really a slope of 1? It doesn't matter. What matters is that the slope is positive, so I'm going to draw an increasing tangent line. A slope of 1 should make a 45-degree angle. This is close enough. If you really want to get particular, sometimes I write m equals 1 on there. Okay, 1 point down, 11 more to go. I'm then going to pick another point. It doesn't matter which one you pick. I'll say negative 1 comma 1. The slope is negative 2 times negative 1 over 1, which is 2. Now I'm going to draw a tangent line with a slope of 2. Now here's where I want to be careful. If my tangent line has a slope of 2, that has to be steeper than a slope of 1. I want to make sure it looks steeper so that the College Board folks know what I'm doing. And all I'm going to do, I'm going to keep finding all those slopes. dy dx at, well, negative 1, 0 is not one of the points. But negative 1, negative 1 is. So dy dx at negative 2, negative 1, negative 1. Negative 2 times negative 1 divided by negative 1 is negative 2. Sorry, you can't see that. That just means we're going to have a decreasing line, pretty steep. And if you keep going down the line, you're going to get slope of negative 1 over here. I'm not going to do all of these. This isn't where I want to spend a lot of time. I do, however, want to look at this next column of points. Let's see. Now these are points like 0, 2. And if I find dy dx at 0, 2, well, plugging it in, I'm going to get negative 2 times 0 over 2, which is 0. How do I draw a tangent line with a slope of 0? That's right, make it horizontal, perfectly horizontal. Well, what if I find dy dx at 0, 1? Negative 2 times 0 over 1. Well, that's 0 as well. Another horizontal tangent line. Well, what's going to happen if your smarticle particles are starting to connect here? The derivative expression is negative 2 times the x value divided by the y value. Anytime the x value is 0, at least for the points that I'm looking at, that means that the numerator is going to be equal to 0, and I'm going to get a 0 slope. Now, what I would encourage you to do is finish making your slope field. Look at those last 4 points. Give yourself a little bit of time to do that. right? 1 comma 2, 1 comma 1, 1 negative 1, 1 negative 2. Eventually what you're going to get is that your slopes are going to pretty much mirror what you have on the other side here. Okay, so there we go. Those are your slopes. I don't want to spend time doing that. The College Board will likely award 1 point for all of your horizontal tangent lines, and then 1 point for all of the others. Slope fields used to be a really big thing on the AP exam. It stopped being a big thing. I think it just, kids understood what to do, and so it's not really testing too terribly much a deep understanding of calculus. Let's keep going. Okay. Part B says let y equal f of x be the particular solution. So that means the equation that would actually work in this differential equation to the differential equation with the initial condition f of 1 equals negative 1. We still have that dy dx is equal to negative 2x over y, and we have the initial condition f of 1 equals negative 1. Write an equation for the line tangent to the graph of f at the point 1, negative 1. Use this to approximate f of 1.1. Equation of tangent line, we've done that a lot in these videos. We've done it a lot in class. I would hope you know exactly what to do. We need a point. We need a slope. The point they gave us is 1 comma negative 1. How do I get the slope? We're going to go to the differential equation. So dy dx at 1, negative 1 is negative 2 times 1 over negative 1, which is positive 2. Equation of your tangent line, L of x equals 2 times x minus 1 minus 1. You found the slope. You use the point slope form of a line to generate the equation of the tangent line. And then the last thing is they want us to approximate f of 1.1. Well, we've been doing that all year. The value of the function at 1.1 is approximately the same as the value I get out of the tangent line at 1.1. Well, that's 2 times 1.1 minus 1 minus 1. Hopefully your calculus teacher has told you repeatedly, if you're on the free response part of the test, don't simplify. It's not worth it. I would assume you'd probably get 1 point for coming up with the slope, maybe another point for coming up with the equation of a tangent line, and then a third point for determining the approximation to the value of the function. Not too bad. Pretty standard part A and part B. I'd expect lots of students to earn lots of points here. Let's keep going. In part C, we're asked to find the particular solution to y equals f of x to the differential equation with initial condition f of 1 equals negative 1. And at first you might say, well, isn't that what we just did over here? No, in part B, they said let y equal f of x be the particular solution. We didn't need to know what that solution was. We just wanted to then take that information and come up with the equation of the tangent line. Here, when they say find the particular solution, this is like solve the differential equation, solve the diffie-q. Well, our differential equation is dy dx equals negative 2x over y. And one of the techniques that we studied this year is called separation of variables. I love this technique. I think it is a great technique to study in AP Calculus. It is a relatively basic technique for solving differential equations. For those of you that are going to go into engineering and you're going to study higher level mathematics, there are a lot more methods out there. But separation of variables, it's well named. We're going to separate the variables. We want to get all the x's and the dx's on one side, all the y's and the dy's on the other, and we're just going to use basic algebra here. So dy dx equals negative 2x over y. I'm going to multiply both sides by dx. dy equals negative 2x over y times dx. I have not solved the differential equation. I'm sorry, I haven't separated the variables yet because I still have a dy on this side and the y in the denominator over here. Well, that's easy to fix. Multiply by y again. Y times dy equals negative 2x dx. Because I'm able to separate the variables here, what this tells me is that the equation is separable. This is classified as a separable differential equation, which means I'm going to proceed down this road. Normally, the College Board awards 1 point if you're able to successfully separate the variables. Now, you want to be careful, because the other thing that they'll do is if you make an algebra mistake getting here, if you don't actually separate the variables, they will award you no points. And that is sad news. So let's keep going. Now that you've separated the variables, we're going to integrate both sides. And the integral of y with respect to y is 1/2 y squared. The integral of negative 2x with respect to x is negative x squared plus c, your constant of integration. Now, at this next point, here's where you're going to make a choice. Some of you like to take the initial condition. What was that initial condition? We have the initial condition f of 1 equals negative 1. The initial condition is a point on this curve. Specifically, it's the point x equals 1, y equals negative 1. Some people like to take the point and plug in right now and solve for the constant of integration. That's great. Other people like to solve for y first, then use the initial condition to solve for the constant of integration. That's good too. It doesn't matter. Sometimes one method is better than the other. I'm going to solve for y first. I'm going to multiply both sides by 2. So I get y squared equals negative 2x squared plus 2 times Charlie. Now, your constant of integration is a constant. You don't know what it is yet. And so I'm a big fan of this thing called Super Charlie. Super Charlie is just a replacement constant. Y squared equals negative 2x squared plus c. To solve for y, we're going to take the square root of both sides. And whenever we're solving an equation by taking square roots, you have to consider the positive and the negative version. So here's the thing. Your answer is either going to be y equals the square root of negative 2x squared plus Charlie, or it's going to be the negative of negative 2x squared plus c. But it can't be both, because when we solve a differential equation, we want our solution to be a function, we want it to be continuous, and we want to make sure that we indicate the domain. So let me identify those 3 things. Your solution has to be continuous, it has to be a function, and I'm a big fan of making my students indicate the domain. Well, the reason why we can't have y equals plus or minus is that we'd actually be generating 2 different graphs. And if you were to sketch both of them, you're going to fail the vertical line test. How do you decide positive or negative? You use the initial condition. We know that if x is equal to 1, y has to be equal to negative 1. Well, that's only going to happen with this bottom version. So I'm going to eliminate that choice. Now I'm actually going to use the initial condition to determine the value of Charlie. We know that if x equals 1, y is negative 1. So that means negative 1 is the negative of negative 2 times 1 squared plus Charlie. Negative 1 is the negative of 1 squared is 1 times negative 2. If I square both sides, you'll get 1 equals negative 2 plus c. So c is 3. Your final answer will be that y is the negative of the square root of negative 2x squared plus 3. This is a complete answer, except for the fact that we haven't talked about the domain. Now the domain, I don't want anybody to get too overwhelmed by this next part, and I'll explain in just a second. The College Board, in terms of separable differential equations, they normally award 1 point for separating the variables. Depending on how complex the integration is, they'll award 1 point for the integration step If it's something more complicated, possibly 1 point for each. 1 point for remembering to include the constant of integration. Another point for using the initial condition to solve for the constant. And then 1 point for coming up with the final answer. Now, the College Board scoring rubric, they always indicate what the domain is, but I've never actually seen them dock a point or award a point for the domain. So, well, what's the domain? Domain, it's all the values of x that you're allowed to use in this particular function. Well, let's see. Issues, we always look for, are we dividing by 0? No. Are we taking the square root of a negative number? Possibly. So my domain has to be all values of x such that negative 2x squared plus 3 is greater than or equal to 0. I want to make sure the radicand, the thing underneath the radical, is greater than or equal to 0. Solving, I get negative 2x squared is greater than or equal to negative 3. If you divide by negative 2, be careful, mathematicians, x squared is going to be less than or equal to 3/2, right? When you divide by a negative, you take the opposite sign. If x squared is less than or equal to the square root of 3 over, if x squared is less than or equal to 3/2, that means that x has to be less than the square root of 3 over 2, but it also at the same time has to be less than or equal to. You also have to be greater than or equal to negative square root of 3 over 2. In total, this is probably a 5-point question. The domain in the middle of the test, probably don't want to do it. They're not going to award a point. They're not going to withhold a point. I just want to make sure that I'm building complete mathematicians who are ready to go off to college and understand the importance of the domain. Okay, last part with question number 1. Here it comes. In part D, describe all points in the plane, that means like the xy axis, where the solution curve will have a horizontal tangent line. Well, let's make sure you can see the slope field. What does it mean to have a horizontal tangent line? Well, that means that dy dx is equal to 0. Now, a common mistake, such a common mistake, kids are going to say, oh, I made a slope field. I know where my tangent lines are horizontal. 1, 2, 3, 4 times. And they're going to list those 4 points and be done. But remember, what made these tangent lines horizontal? It had to do with the fact that your derivative was equal to 0. Specifically, the numerator was equal to 0. What we need is for negative 2x to be equal to 0, which means that x equals 0. Now, I want to be careful because the scoring, the solutions that were provided by one of the calculus teachers on our team has x equals 0 as the solution. That's actually not correct. There is a place where the x value is equal to 0 where your derivative won't be 0, and that happens when the y value is equal to 0. If the denominator is equal to 0, your fraction won't be equal to 0. Your fraction will be undefined. So specifically, we need x to be equal to 0, but y not equal to 0. Any points where this is true, the x-coordinate is 0, but the y-coordinate's not equal to 0, you're going to have a horizontal tangent line. That's the complete answer, and that's worth 1 point. So that's a pretty standard question. I hope you did well with that. We're about to move into a more complicated differential equation, but it's going to be a really important one. All right, friends. So now we've got a second question. This is still on page 72. This is from our friend Stu Schwartz, the Master Math Mentor. He does great stuff, but man, these questions are tricky. When a dam is built, the water from the river that is being dammed is blocked so that the dam can be built on a dry site. As the dam grows higher, residual water from the surrounding ground will collect behind the dam. At the Newton Dam, the water is 30 feet high at the time the dam is finished and the river is unblocked. Okay? The height h of the water after the river is unblocked satisfies this differential equation. Okay, dh dt equals 1 over 12 times h minus 10. H is measured in feet. T is measured in months. Okay, the model is in effect for the next 2 years. Okay, that's going to be important. Okay. A, use the line tangent to the graph of h at t equals 0 to approximate the height of the water behind the dam at time t equals 1.5 months. So, equation of the tangent line at t equals 0. We did this in the last one, so I'm going to go a little fast. I need a point. I need a slope. The point is when t is equal to 0. I need to know the height at t equals 0. They told me that earlier is going to be 30 feet. I need dh dt at 0, 30. Plugging in, I'm going to get 1 over 12 times 30 minus 10, which is the same as 1 over 12 times 20. You get 20 over 12, and that's 5/3. That's also a huge waste of time to simplify. But okay. We're going to write the equation of the tangent line. Now I know we sometimes write L of x, but it's pretty clear that t is my independent variable. So L of t is going to be 5/3 t minus 0 plus 30. That's the equation of my tangent line. They want me to approximate the height at 1.5. The height at 1.5 is approximately the value I get from my tangent line at 1.5, which is 5/3 times 1.5 plus 30. I don't care what it simplifies to. For those of you that are hungry for that, 32.5, and the units would be feet. Part A, not too bad. I would expect high degrees of comfort here. Let's keep going. Part B, find d squared h dt squared to determine whether your answer in Part A is an underestimate or an overestimate of the height of the water behind the dam at time t equals 1.5. Okay. D squared h dt squared. That notation should be familiar to you. This is your second derivative, which means we're going to find the derivative of the first derivative. But we want to be careful. This is a derivative with respect to t. So take the derivative with respect to t of 1/12 of h minus 10. Now, if you want to distribute, feel free. I'm not going to bother distributing. A constant times a function, when I take the derivative, you leave the constant alone, and you take the derivative of the function. So 1 over 12, the derivative of h minus 10 with respect to t. T is your variable, is dh dt minus 0, or just dh dt. So you get 1/12 dh dt. Again, the reason is that we're taking the derivative with respect to time. T is the variable, but I'm taking the derivative of h. Now, you can go further and say, well, we know from earlier that dh dt is 1/12 of h minus 10. So let me plug that in. Multiply it out if you want to. You're going to get 1 over 144 times h minus 10 is your second derivative. Now you might be thinking, why did they ask me to find the second derivative? Because they're guiding you. They're guiding you to be successful here. You want to determine whether you have an underestimate or an overestimate, and we've talked about this a lot in class. To do that, you're going to have to look at the concavity. You want to see how the curve bends. If your graph is concave up, when you draw in tangent lines, those tangent lines are always above the graph. If the curve is concave down, tangent lines are above the graph, your estimates are over estimates. If your graph is concave up, your tangent lines are below, and so you're going to get underestimates. What you've got to be careful about, and this one's really tricky, you have to talk about concavity from your point of tangency to the point that you're estimating. Well, how can I possibly determine the concavity? What I need to know is the sign of the second derivative. What I know is that at time t equals 0, the height is 30. And if you read the question carefully, you get out of it that the height is increasing. What that means is that from time t equals 0 all the way to time t equals 1.5, that height just grows and grows and grows. The height's always going to be greater than 30. Your second derivative then is going to be 1 over 44 times h minus 10, but h is greater than 30, so your second derivative is always going to be greater than or equal to 30 minus 10 times 1 over 144, which is positive. Since your second derivative is positive on this interval, h is concave up. And as we mentioned earlier, if your graph is concave up, the tangent lines are below the graph. Which means that what you get is an underestimate. Let me scoot that up. Sorry. Okay. Finding the second derivative was tricky because you needed to know to use related rates. You then, once you found the second derivative, you needed to consider what do we know about the function on the interval containing the point of tangency to the point that you're approximating. And then you had to talk to me about the sign of the second derivative, how that tells you about the concavity, what that tells you about the tangent lines, and whether you get an underestimate or an overestimate. This is probably at least 3 points, and I got to tell you, I think a lot of students are not going to earn a lot of points here because they're going to blow it on the derivative in the beginning, and everything falls apart. Okay, let's keep going. Got to take the kid to a soccer game. All right, part C. Find the particular solution. Okay, solve the differential equation. H of t to the differential equation dh dt equals 1 over 12 times h minus 10. With initial condition h of 0 equals 30. Then find an expression for the height of the water after 2 years. Okay, let me pause for a second here. Sorry, I needed to go move the kid along for soccer practice here. Okay, we want to solve the differential equation just like we did before. So we're going to get all the, before it was x's and y's, now it's h's and t's. All the h's on one side, all the t's on the other. I'm going to multiply both sides by dt. dh is 1 over 12, h minus 10 times dt. That's a 10. I need to get all the h's, but h minus 10, that's all together in parentheses. That's going to have to get divided to the other side. That is your separation of variables, and you just locked in 1 point. Integrate both sides. The integral of 1 over 12 with respect to t is 1/12 t plus Charlie. The integral of dh over h minus 10, well, whenever you have the form 1 over x plus a with, if you're integrating 1 over x plus a with respect to x, you're going to get the natural log of the absolute value of x plus a. What do we have here? We have the integral of dh over h minus 10. That is the natural log of the absolute value of h minus 10. You need to solve this equation for h, so get h by itself. To do that, we're going to exponentiate. There we go. Absolute value of h minus 10 equals e to the 1/12 t plus Charlie. You don't have to, rewrite this as e to the 1/12 t times e to the c. When the bases are the same and you're multiplying, you add the exponents together. C is a constant. E is a constant, so e to the c is a constant. We get c e to the 1/12 t. You're trying to solve for h. To do that, we're going to remove the absolute value bars. But you don't just throw them away. If the absolute value of h minus 10 is equal to this, then h minus 10 without the absolute values must be equal to either the positive or negative version of c e to the 1/12th t. Here's another place for Super Charlie. C is a constant. Whether it's positive or negative, it's still a constant. So here's Super Charlie again. H minus 10 is equal to c e to the 1/12th t. Add 10 to both sides. We're almost done. Remember, there's an initial condition. We had the fact that when t equals 0, h is equal to 30. Plugging everything in, we get 30 equals 10 plus c e to the 1/12th of 0. That's still 0. E to the 0 is 1, and you get 30 equals 10 plus c. So c is 20. Final answer, h equals 10 plus 20 e to the 1/12th t. Sorry, that's so ugly. Jackie's really upset right now. Now, before we wrap up and I head out with the kiddo, they asked for the height after 2 years. We have done beautiful, beautiful work. Don't blow it now. The height after 2 years, the foolish mistake is going to be for the kid that says, oh, you want me to find h of 2. Why is this a mistake? You might be thinking, why is h of 2 the wrong thing to do? T was measured in months. They want the height at 2 years. Don't find h of 2, find h of 24. H of 24 is going to be 10 plus 20, e to the 1/12th of 24. 1/12th of 24 is 2. The height at time t equals 24 is 10 plus 20e squared. The units should be feet. Congratulations, friends. You are done. If you can make your way through this one and the second derivative stuff, you are in great shape. Remember the key phrase, Justice League.